Hello guys, today we will do lab 2 about DC high voltage measurement and monitoring. The objective of this lab is construct a parallel DC high voltage measurement setup using kit control 4.0 and picoscope 4000. Understand the procedure to configure kit control and picoscope for DC measurements, and also compare DC reference readings, kit control with actual display picoscope and analyze it. Those components that we're going to use to construct the circuit is 6 floor pedestal with a 4 space bar,
The
and
main
also
thing is
6
using
connecting
diode
cup,
for can be
two
used for
collection of
impulse and
rod,
DC voltage
3 insulating
configurations.
support,
The
1
diode
electrode,
consists of a
and 1
protecting
grounding
resistor
switch,
and high
1
voltage
measuring
diode. We're
resistor,
using two capacitors.
1 measuring
One capacitor is
capacitor,
for smoothening and
2
also
high
energy
voltage
storage,
diode.
and one more is measuring capacitor. The smoothening is because can be used as an energy store capacitor generation of impulse voltage or as smoothing capacitor for DC generation. Then we use a grounding foil to connect all equipments of grounding. We also use resistor quantity of 2. This resistor works is discharge resistor for DC, impulse voltage configuration, parallel resistor in impulse voltage configuration. We have two secondary equipment for current. One is AC, one is DC. So in this construction of the circuit, in an electrical installation, the secondary AC is a component of the measuring system, especially for alternating current. It uses signal for main equipment, including current transformers, rather than being directly linked to high voltage power lines. Its main function include current measurement, signal condition, and also data output. The secondary is DC, secondary equipment for remote measurement DC. The kit secondary DC is a component of the secondary system intended for the measurement and monitoring of DC, especially in remote measurement application like DC distribution panels, power substations, and battery system. Its main function include DC voltage and current measurement, signal processing and condition, and data transmission. Then from the AC secondary and also DC secondary, there is channel A and channel B to the picoscope. So how we said is AC we will be in the channel A and DC will be in channel B. And also AC we will use VM1 and DC we will use VM6. Okay, for picoscope we will use kit control and also kit measurement. For kit control we're gonna use 4000 and we're gonna use kit lab control. Once the kit control appears, we will click to this setup. The setup we will see MC setup, and also we do not change anything. Second, we will click the custom setup. Once the custom setup appears, we do not change anything except the calibration. So the first for the calibration, we're gonna use VM1. So VM1 is a slot 1 and slot 2. So we can pick either one. So I'm picking up slot 2. And we will see the serial number. My serial number for the AC is 2234107604. Then we have also to slot on the DC to the BM6, and my serial number for DC is 22341182-06. After setting up the proper serial number, then we have to save the setting. Then once save everything, then we will go to the measurement kit. Once we go to measurement kit, we have to change the ratio. We have to set the divider ratio. So for the channel A, I already set up AC, so we have to change the divider ratio in the paper that been given for our serial number. And also we have to change the coupling AC. The calculation of the range is given kilo voltage divided by ratio divider for AC. So once come to channel B setting has the same. We have to set up the ratio, but the ratio we have to set up by the DC serial number. Then coupling we have to change to DC, and channel B we have to choose DC. Then also the range we have to given kilo voltage times by square root 2. From that answer, divide by the ratio divider. Then you will get the range. Not to be specific that you will get the range answer. You will get might be similar like a 4.8, so we choose 5. 3.8 we choose 4. Something like that. So we confirm that we cannot choose the exactly value like we calculate. We have to choose the nearest value. Like 4.5, 4.8, we have to choose 5. As a final result, you can see that my AC is a positive value and my DC will be a negative because we are running the DC as a negative value.